has an internal resistance of 10 mega ohms, then what the multimeter sees is not just the 1 mega ohm. It will see this. I'll see the 1 meg in parallel with the what? 10 meg. Most of your multimeters have an internal resistance that's so high that you can just count that. But if this only has a 10 mega ohm internal resistance, then that's going to affect what this reads. So instead of reading just a 1 meg, it's going to read the resultant of both of these, which is going to be a 1 in parallel with what? And this 1 meg. How are we going to do that?
That's the wrong man. Are you looking at me? Come on, man.
I know. Huh, Dave? How are we going to do that? Yep. What are you going to do? That's 1 times 10 divided by 1 times 10 is what? 1 plus 10 is? That equals 0.909. So, it is actually going to measure 0.909 mega ohms. Now, what would happen if this had an internal resistance of 100? So let's see. If our multimeter has a higher resistance, let's see what the difference is. So instead of 10, now it's a 100. So we change that to 100. So now what happens to my equation down here? Does that. So now that becomes what? 100, and that becomes what? 101. Now do the math. See what you get. 100 divided by 101. Do it on your calculator.
I have a calculator.
You don't have a lot.
Like what? 100?
101.
101?
0.990099.
0.9900. So we went from 0.909 to what? 0.99 mega ohm. So you see what a big difference that makes. You want your internal resistance of your multimeter to be as high as possible. You want it to be infinite. If it's infinite, then it acts like a what? An open circuit, and then that resistor doesn't exist, and then you read just a 1 mega ohm. So the higher the resistance of the internal resistance of the multimeter is, the closer you're actually to reading the actual value of that resistance. Make sense? You got it?
No, it's a negative.
What's the answer? Thank you.
The answer is this. So what will you read? I will read 0.909 mega ohm.
Oh, that blue one you just had like for another example?
Yeah, the green one.
Is the actual question, the blue one?
That's what we'll actually measure. And then what I did, I said, what happens if this has an internal resistance of 100? Oh, right. Oh, okay. Oh, okay. So now that we know what our resistance is, let's get rid of that. Now I can do my what? Voltage divider, right? Right? Because if 20 volts go in, how many volts have to come out? 20. So, if 20 goes in, 20 has to come out, then I can do my voltage divider, so that would be R1, that would make it R2. So, say if we did this on R2, it would be R2 divided by R1 plus R2 times what? 20 volts. Now we know R2 is 0.909. R1 is 1, so that would be 1.909 times what? 20 volts. So equals measuring that. What are we looking for? What you will read how many volts? Because you're trying, if you measure the voltage. So first off, I had to figure out the difference in the resistance. If they're both 1 meg, then it should read 10 volts and 10 volts, right? But since my multimeter has an internal resistance of 10 megaohms, it's going to change how this is read. So this will drop how many volts?
That's multiplying, or it's got one, you gave them one function underneath with the 909, then it's got the flash.
Okay, so I got R2, which is 0.909, divided by R1 plus R2, which is 1 meg plus 0.909, which is 1.909.
Okay, now I just see a dot right there. So 1 plus 909?
Yeah, R1 plus R2.
Is 1 point.
Yeah.
Alright, 1.47.
Yeah, so that's 0.909, and that's the B1, and that's right, 0.909. So 9 over that times 20, and what you come up with? 9.47. So that's going to read 9.47 volts over this one. And then the difference, if you have to add up to 20, is going to be 10.53 volts over that. But it's just basically asking you, if you measure the voltage across one resistor, when the digital multimeter has a very small resistance of 10 megahertz, you will read